Hey everybody, and welcome to our talk about Grox. Grox is an open source library. You can find it in GitHub. The link is here, that we created while developing the main Groupon app. So it helped us solve a very specific problem that we had in our app, how to manage the state. So first, let us introduce ourselves. So hi, I'm Alin. I come from Romania. I've been doing Android development for about 7 years, starting with 1 point something, and together with my colleague Stéphane, we were part of the team that created Grox, and now we are currently some of the maintainers of it. So I'll let Stéphane go.
Yeah. When you say Romania, is it the country of Dracula?
Yeah, but don't worry, I came alone. So.
Oh, you came alone. Okay, that's good. So, and my name is Stéphane. I'm a senior Android developer at Groupon. As part of my assignments, we contribute to open source software. So we release open source software, we maintain them. One of them is Toothpick, a dependency injection engine that we released like 2 years ago, which is actually a very good choice for Android. So it's easier to use than Dagger, and almost as fast, even sometimes faster. So up to you to choose it, but for testing, it's really a charm compared to Dagger. And we also released Dart and Son, the version 3, very recently, which is, as far as I know, the only navigation library that is compatible with modularized applications. So if you're interested, you can check it. They are all on GitHub. And today we're going to present Grox, which we also released at the very beginning of last year, I think. So the plan for the session today is going to begin with an introduction about the origins of the library. So we picked up a few ideas from a bunch of libraries that you might know. And then we're going to talk more specifically about the concern that we're trying to solve. So Alin said it was the state management, but what does he mean exactly by that? So we will be explaining that a bit deeper. And while doing so, we are going also to explain what are the ingredients or the basic bricks, the basic entities inside Grox, so that you can understand the design. Then we will exemplify all this with some code, where we're going to present the main entities inside the Grox core artifact, which is the main artifact of the Grox library. Inside you can find a store, also actions and middleware, so we will explain all that, what it means. And we will also go through the Rx store, which is an extension of the Grox core, especially designed for Rx to make the code more reactive. And then we will explain what is a command, which is really the most Rx-tied part of Grox. And we will see how to wire everything together in a typical Grox application. Let's get started with the origins of the library. So we got inspired by a few different sources. The first one is Redux, which can look a bit strange maybe on Android, but it's a very well-known library in the JavaScript world, which is also an open source library. You can find it on the web. So yeah, we took some ideas from Redux, also some ideas on Flux from Facebook, which is also available on GitHub. And last but not least, we were inspired not by a library, but by a talk that was given by Jake Wharton, maybe like 2-3 years ago. So the name of the talk is Managing State with Rxjava. Actually, if you never looked at it, we really strongly advise to watch it. It's really a deep dive into Rx and how it can solve non-trivial problems like state management, for instance. So I will pass it over to Alin to start giving a bit more about the context and the issue we're trying to solve inside Grox.
Yeah, so a problem for a lot of us is that our apps grow and grow and grow. And as they grow, the logic becomes more entangled, you have different components talking to each other on different threads. So we have now database, you have multiple network calls, user interactions. So I think the main issue that most of us have is how to maintain a clear internal state. So as I said, all our components interact on different networks, with the network, with the file system, on different threads, at any time and from anywhere. So you can easily change the state from any point. And also another problem is that our state is stored in multiple places usually, maybe some in the presenter, some in the activity, fragment, you maybe have a manager or something. So our current state is quite unclear, and changes are very hard to track. And if you think about it, everything in the mobile world is asynchronous. So you have callbacks, the database, the user interaction, the server interactions, they are all asynchronous operations. So there's a lot of concurrency issues. So at some point, you no longer understand what should be displayed right now, what are we doing right now, and you come up with a bug report, and you're looking at it, and you say, wow, this should not be possible. How did the user end up in this state? And then you try to debug, you find the corner cases, and at the end of the day, you hate yourself for the code you wrote. So let's take a typical example, interacting with a file system and performing a network request. First, I'll focus on these two operations. So this is a common use case. You just fetch something from the network, display a loading screen, and when the results come back, you display it on the screen. The first thing we do is to extract the logic of this operation, and next we encapsulate it in our code. So now we have a common place where you do that operation, a component that does it, and your app only wires these components to the UI. So it's not involved anymore, so we can remove it from the diagram. Now, I'll let Stéphane explain what happens when we add the second operation.
So here on this diagram, you can see that we're going to perform two operations at the same time. So on the left, we're going to access the file system. On the right, we're going to perform a network request. So far, everything is going pretty well, except that in most cases in our applications, we're going to tend to program everything inside the activity, or maybe inside the fragment, the activity, the presenter. And you could have, for instance, one Boolean flag to say, oh, I'm going to prepare this network request. Maybe it's going to be inside a fragment. And maybe for the file system, it's going to be some part of the state inside the activity. And maybe some part of the state is going to be stored inside the view somewhere. So your state is all scattered. And the problem is that even if your state would be like centralized inside a Pojo, at some point, your code is going to come back from these operations you're performing, like accessing a network or accessing the file system. So you come back into your application, and both of these operations are going to try to access the state at the same time, which means concurrency issues, but it also means that basically, you don't know in which order the things are going to take place. Maybe the network is going to come back after accessing the file system, or the other way around, or maybe just one of these operations. So you're very fast, only with two operations, we clearly lose a clear state. We don't know exactly in which state we are. So to address this problem, we're going to introduce a state repository, which we call the store inside Grox. This state repository, or this store, is going to be the unique source of truth inside your application. It's going to be the only component that stores the unique state of the application. So that's quite a constraint, but you'll see it make things much easier. So the responsibility of the store is going to hold the state, but also to update it and to notify some other parts of the UI that the state has been changed. So now we have a unique clear state, and yes, our model can scale because we can add more operations and they will just work in the same way as these two first ones. I'm going to let Alin explain what are the entities on this diagram and their relations.
Yes, so now we have a pretty good idea on how our design looks like, our state management design looks like, but as in any design, you have to have clear concepts for every entity inside the design. So let's see how these arrows and these components map to entities in our code. So the first one, the arrow from the store to the UI, represents a stream of states. So as operations change the state inside the store, your UI will be notified of the new state and it will use it to display it. So these are the stream of states and the UI will react to them. You all know the saying, the eyes are the window of the soul. Well, in our design, we like to say that the UI is the window of the state. So the sole responsibility of the UI should be to take the state and display it. I'll let Stéphane continue with the next components.
So on the same diagram, you can see the white arrows going from the operations to the store now. So this is a stream of state changes. In Grox, we name state changes actions. So here we have a stream of actions. So we basically mix together all the different state changes that you can get from all operations and direct them to the store. And we call this stream a stream of actions. Here at the very top of the screen, from the UI, we're going to get events, so from user interaction, people clicking on buttons and performing stuff like scrolling. So again, we consider this as a stream of UI events. We will see there are a few libraries to help us actually modelize that in the code in an easy way. So at the very top, we have a stream of UI events. These events are going to trigger operations in the red squares, red rounded squares. In Grox, we call such operations commands, because we like to redefine everything. Otherwise, we cannot give talks to droidcon. So, commands are triggered by UI events, and they will return a stream of actions directed to the store. So now, if you look at the picture we got on screen, we got very clear concepts. So we got the store, we got the state, we got actions that are state changes, and commands that produce a stream of actions. And also we got the UI events. We also got unified processes, because we can represent any kind of operation by the red squares as commands. So we can access the network, we can access the file system, a database, perform a long-running operation, whatever. Everything can be represented as an operation, as a command. And last but not least, it scales. So it means your app can become as complex as it wants to be, and we can still represent it inside Grox. So all of this together makes a thing that, yeah, we have a design, and that's actually the design of the Grox library. So let's see a bit more of the design overview of Grox. So let's take a simple example. We are inside the Groupon application. There is a buy button so that our users can buy amazing deals from Groupon. Then we are going to transform this button, or to see it as a stream of clicks, a stream of UI events. Then from these events, we're going to map them into commands. Between the events and the commands, there is a one-on-one relation. So one event is going to trigger one operation. Then from this stream of commands, we're going to transform it into a stream of actions. And the relation between commands and action is a one-to-many. So one command can actually create multiple actions. I will let Alin detail this in a second. And now we have this stream of actions, but remember, actions are just state changes, so we can now produce a stream of states. And every action is going to be responsible for passing from one old state to the new state, and this creates our stream of states. And we can redirect this stream of states to the UI and let the user know that the purchase operation was successful. And all operations are going to be represented in this way with Grox: events, commands, actions, and states. There is no exception. Now I'll pass it over to Alin to give more of a sequential approach to explain what's happening inside a real Grox application in real time.
Yeah, so before we jump into code and examples, I'll provide you another overview with a login example, which we will use to the rest of the presentation, because we all have some login in our app. So let's see what happens when a login click event is performed. So the user clicks the login, and then you get a login command that will generate a login in progress action that will change your state to display a progress on the UI. Next, when the net request is finished, we have a login successful action that again will change the state. We'll use that state to display something on the UI, maybe the user information. So yeah, this is basically a timeline of Grox design. Let's see what are the building blocks for you to create this design. So Grox comes with 3 artifacts, 3 jars that you can use independently to create this design. The first 2 are the Grox core and the Grox core Rx extension. And this is about actions, states, and the store. So we have the store, which is a state repository. It's the unique source of truth. And we highly recommend that you use an immutable state. Here you can use auto value, or if you're using Kotlin, they are built in. Another thing that the store has is a reference to an observable of states. So using this reference, you can observe for state changes. Actions are received by the store using its dispatch method. And when an action is performed, it will use the old state to create a new state, replace it in the store, and then you will be notified of the new state. So basically, the store holds the state, dispatches action, and notifies of state changes. Now, as I said, we have an Rx extension of the store that we use, and the rest of the presentation will use the reactive way of using the store because we are using it like that, and in our opinion, the reactive way is the way to go for mobile, but that's a different topic by itself. So you have the Rx store that has the state methods that will let you use the store as a stream of state, an observable of states. So you can subscribe to it and be notified every time a new state is produced. But Rx is optional. You can also use it in a traditional way with a state change listener. Let's see a concrete example how we can create a store. So once we create a store, you will give it an initial state. Once you subscribe to a store, you will always get immediately the current state. Next, as I said, we will use the states method from Rx store to generate an observable of states, and when we subscribe to it, we update the UI. Now, this would work with a presenter also, or a view model, it doesn't matter, so it's agnostic of the presentation layer that you use. But the important thing is that the UI will react to state changes. Let's see how an action looks like. So you create an action by implementing the action interface, which is typed to the state model, in our case the login, and then you override the new state method that will receive the old state that you will use to create the new state. In this example, we are using auto value, and from the old state, we just override the login state with a login success, and we also save the logged in user that we receive from the network or from the database. The important thing here is that actions are pure functions to create states. So they don't depend on the network, they don't depend on the file system or the weather or the fire, right? They are 100% reproducible and they should be very testable, right? 100% testable. Next, I'll let Stéphane talk about the middlewares.
So Alin just showed you what the store looks like, what the actions look like into Grox. There is a third component inside the Grox core artifact, which is called middleware. To be truly honest, you're not going to use middlewares on a daily basis. We use them very scarcely, very rarely inside Grox. But still, it's good to know what they can do. So middlewares, the idea is that they are going to be able to intercept actions. So you can use middlewares to add features, to add functionalities to your store. We will see in a second a few examples. Middlewares are arranged into a chain, so they form a chain. Here you got 4 middlewares symbolized by the purple triangles. And what is important is that there is an order in this chain. So from left to right, the first interceptor to the first middleware to intercept the action, and on the right-hand side, the last one. So when an action is dispatched by the store, all the middlewares are going to see this action before it is executed in order of the chain. So first, the first middleware on the left, and the last middleware on the right. And so this is prior to the execution of the action, so before we change the state in the store. So at this level, the middlewares can do stuff on the action. We'll give a few examples in a second. Then, once we reach the end of the middleware chain, the action itself is being executed, and so it switches the old state to the new state, and it's replaced in the store. And then the middleware chain is going to see the action again, but in backward order, in reverse order. And so the middlewares can also intercept the action after it has been executed. This implementation is very, very close. Actually, it's almost a copy, I would say, of the interceptors of HTTP clients, if you guys are aware of the library. And it was a very interesting implementation, so we were very happy to take it from there. So yeah, the concept is really clearly equivalent. So how to create a middleware? It's pretty easy. Like everything in Grox, you just implement an interface, which is typed by a generic type about the model class, the state class. So here you will have to implement the intercept method, which takes a chain as a parameter. And the most important idea is that you will have inside every intercept method to call the method chain.proceed. So when you call this method, you're saying to the next middleware in the chain, okay, that's your turn now to intercept. So you have to call this method. Otherwise, at runtime, we're going to throw an error. The idea is that before the call to proceed, so from the signature of the method to the proceed call, you will see the action before it is executed. So we still have the old state, the action has not been executed yet, and you can intercept it. After the call to chain.proceed, then you can see the action after it has been executed. So typically, we use middlewares to log stuff, to report crashes, to persist the state also if you want to survive the death of the process or your activity. So a very typical example would be to report, for instance, all the state changes that took place inside your store, and you can add them to your crash reports. So when you receive a crash report, you can see all the sequence of states that your user has gone through, and you can understand what he or she did before actually experiencing the crash, and you can reproduce this state and just reproduce the crash. This feature is called time travel debugging. And again, it's something we took from Redux or Flux, I don't remember exactly. So yeah, here is the basic implementation. So let's wrap it up. Inside the Grox core, we got 3 main entities. The first one is a store. So the store holds the state. It emits a state on an observable, and it dispatches actions. Actions are going to produce a new state given an old state. And middlewares are here to intercept state changes and basically add functionalities to your store. Now we let Alin talk about talk about the comments, the Grox core Rx artifact. Yeah, go for it.
Okay, so the last artifact in Grox is the commands, which are really tied to Rx. So commands are generated by UI events, and they produce a stream of actions. If you are familiar with MVI or you want to implement the MVI pattern, this is similar to the intent. So the intent that you have. Let's see how commands looks like. So you create a command by implementing the command interface, and you override the actions method that will produce an observable of actions. So commands produce observables of actions. Now you can do what you want inside the commands, usually long-running operations like network request, fetching something from the database, accessing the file system, or even long computations. Right here in our example, we perform a login on server. Here you could use a repository or whatever. We can switch the thread. These commands can run on any thread. But the important thing, as you can notice, is that we start with a loading action. So this, even for the start of the request, we have a clear state. So the UI can react to it and display a loading spinner or something. Also, another important thing is that we do the same even for errors, right? So even for errors, we handle the error and we turn it into an action. We don't throw something or we don't use the throwable, right? Because even in this case, we want to have a clear state. We want the UI to react to it, display something to the user that is meaningful. And when we are in a success state, we just do the login success action that I just showed you that saves the user and also notifies the UI that login was successful and it can do whatever. So for all possible outputs of your command, which is not pure, not 100% reproducible, you need to have actions. So you always know in what state you are, right? So this is important. Now I'll let Stéphane see how actions, store, and commands work all together.
Okay, so that's cool. We got a good overview of the store, the actions, the middlewares, the commands. But what does it mean for you, really, if you want to use Grox? What kind of code do you have to write as a user of this library? So basically, you will have to write commands. So commands, remember, they're just operations. For sure, the library cannot write that for you. So you will have to write commands, for instance, to access the networks, the file system, whatever. So this is your code. You will also have to write the corresponding actions. So as Alin just explained, all the output of commands must be actions. So you have to define the actions. And actions are going to be state changes. So you also have to define your state class, which is usually just a basic POJO. So you have to write this code. Once it's done, you also have to wire it together. So remember, we want to respect this diagram, this flow, basically, where we go from the UI events, go to operations, Then we have operations producing actions. They go to the store, which updates the UI, and so on. So this is all the wiring part. Here is how to implement that for real. So first, as you can see on the right-hand side, we want to create the store and we want to link it with the UI, so the state can be displayed. So to create a store, that's easy. You just call the constructor and you pass in the initial state. After that, we're going to wire the store and the UI together. To do so, we call rxstore.states, so the Rx extension of Grox core. So with this method, you can see your store as a stream of states, and you can plug onto it. Here we want to subscribe, so we want to listen to changes and update the UI, which is just a single method reference. That's actual code, actually. If you organize your code cleanly, you can reach this level of conciseness. And because we are going to update the UI, all the views and the widgets, we need this to happen on the main thread. So that's for the first part on the right, where we plugged the store and the UI together. Now we want to do the wiring between the UI events, the operations, the actions, and the store, the second part of the wiring. And you can see you can do it in a single Rx block. So to do so, we use Rx binding, which is a library that was initiated, I think, by Jake Wharton. And this library lets you see UI widgets as emitter of streams of UI events. So instead of having a login button, then you add a listener on it. Here you just call rxview.clicks of this login button. And what you get from this method is a stream of clicks on this button. So we take this stream of clicks. We say that every click is going to trigger a login command operation that we have defined. So here we just use the map operator to say we're going to start a new command given a click for every click. You remember that commands return observable of actions. So here we are going to listen to these observable of action. And for every action that we receive, we're going to dispatch them in the store. So store, : dispatch. And with this block, we wired together a UI element, created an operation, got the result expressed as a suite of action, and then we send that to the store. And then the first chain is going to update the UI as soon as we are going to get actions or new states being emitted. So this last block here on this slide is what you will have to repeat. As long as you are adding commands, you are adding new operations to your application, you will have to repeat this block over and over to map the UI events to the actions or to the commands and the actions. And that's it. That's all you have to do. So the first block remains unchanged, and the second one has to be multiplied by the number of actions or operations. All in all, we think Grox is a good library. Actually, it's not a very complicated library, but yeah, it's efficient.
It provides a design.
Yeah, it provides a design. Maybe we can talk more a bit about how it was adopted at Groupon. It really surprised even us. So Grox provides a few good things to your application. The first one is that you have this unidirectional data flow. So we always start at the UI event level, then we are going through the commands, the operations. Then for every output of a command is going to be an action, which is a state change, which is directed to the store that updates the UI, and we start again. So because there is only one way to modify the state, only one place to update the UI, so this flow is something that really helps you maintain the application. Also, it helps ramping up on the design you've chosen for your activity or your application. It's easy to catch, basically. As we said, with the middlewares, you can also enable time travel debugging. So when you have complex states where multiple, maybe teams are contributed to the same screen, not everyone is aware of all the actions that the users can do. Then with time travel debugging, you can observe that and join this sequence to a crash report, so that people can reproduce easily the state in which the user was in when a crash occurred. Then Grox is also providing a lot of scalability, so you can add as many operations as you want. And that for us is very important because we have a team, we have actually multiple sub-teams, like 4 or 5 teams at Groupon working on the same Android application, and very often on the same screens as well. And so we wanted to have an architecture that is scalable. We can make the screens as complex as we want, add features, A/B test, and whatever. So it scales. Also, it provides a very good isolation of concerns because it's fine-grained. The unit of coarseness is the command or the actions. So every team can be responsible for their own commands, their own actions. They just share a state, but you can also organize the state so it looks like more like a tree of objects where each team has its own subpart of the tree. Also, Grox provides very clear concepts, so it's very difficult or almost impossible to mix them up. So a state is a state, a store is a store, an action is something that changes the state, and it should have no dependencies, no external dependencies. So no dependencies on the network, database, file system, whatever, nothing like that. An action is a pure function. And if you need any external dependency, then you use a command. So you cannot really get confused by that, which is also simpler for maintenance, for adding new feature, for enforcing the architecture. And last but not least, of course, all the the code is testable. So yeah, Pojo for the state is probably testable. Actions are testable because they do not use any external dependencies. They can be 100% reproducible. So it's just an isolation of the state change at the logical level. So you can test that easily. For commands, it goes the same way. You can just mock your external dependencies, and it will work. And if you want to do integration tests, we have a few extra integration tests at Groupon, where we actually inject a state directly into the store, so we can put our state in this state, app in this state, and do something and test that it works correctly.
Bypass the login, for example.
Yeah, bypassing the login, for instance. You like these things, simple, yeah. And one thing that is also cool with Grox is that it's not really a framework. Actually, because you are free, there is a lot of degrees of freedom. So you can use Grox, as we said, with MVP. It also works very well with MVVM. Etienne Caron suggested that he's a GD from Quebec as well. And he suggested that it's almost a canonical implementation of MVI. So if you're interested into MVI, Grox makes it easier. And we have actually solved a few issues for you. Some of them not so easy, but the store is working well, concurrent and everything. Also, Grox works very well with Rxjava. Of course, we have an extension for Rxjava 2 and Rxjava 1 if you're still using it. As we've demonstrated, it also works very well with Rx binding. So the idea of Rx binding is to transform your UI widget into a source of stream of UI events. And it allows you to jump directly from your UI into the reactive paradigm. So you don't have to mix two styles of code, one where you would set a listener and then start an Rx chain. You can do everything into the same block. As we said, we strongly emphasize on the importance of using immutables for the state. So you can use auto-value, for instance, in Java. There is also a library called immutables. I don't know if some of you use it, but you can use it. You're free to choose the library you want. In Kotlin, you can use data classes. I think that's the way they are named. Also, yeah, Grox works well with Java. It also works well with Kotlin. Kotlin makes it a little simpler in a few cases, especially because of the type inference mechanism of the compiler, which is a bit better than Java. And last but not least, we wanted also to mention that Grox works very well with feature adapter. Don't worry if you don't know this library. So it's a library that we've published last year at Groupon. It's pretty fresh. It's actually a library that is very, very specialized. So when you have, let's say, a complex screen, when you want like 12 or 20 or 30 people to work on the same screen, but you want super good performances, you want to make sure it's rendered super fast, then you can use feature adapter. And it integrates also very well with Grox, so you have this unique data flow that we've mentioned. And feature adapter is going to make sure that your performances are going to be amazing, which they are, really. Thank you very much for attending this session. Before taking any questions or comments, we would like to show you a small 3D animation about Grox. So here you can see at the very top of this structure, we got a cube, and the color of the cube is changing every time a white ball touches the cube. So that's your state. When the state is reaching the UI, we update the UI. And from the UI itself, from the top, we're going to emit UI events. Then they are going to transform into commands, actions. They go to the store, and then we emit back to the UI again. The idea with this 3D structure is that you can see that we can represent actually any operation. It scales very well. It's also very efficient for concurrency issues. And you could have as many operations as you want. It would just scale, and that would just work. And actually, that's something that we have demonstrated even in production. It's working well, for real. So thank you very much, and yeah, let us know if you have any questions or any feedback, any comments.
Yeah, since you mentioned...
Great talk, guys. We actually implemented something very similar to this at our company, probably not as good as you guys, but one problem we had was how to represent transient state. It's like, for example, the network request failed and you just wanted to have a brief like snack bar or toast or something that's displayed to the user. But like when we rotate the screen and we get the state again, we don't want to show that snack bar because we've already shown it once. Like, how do you guys manage that?
Yeah, I can take it. So I think the question is you show the snack bar, you rotate the screen, you don't want to show it again. You could save it. You can save it in a state that you showed it. I think that's one.
So just mutating the state again.
Yeah.
So the way we did it was just have like another stream of transient events. But yeah, cool.
Yeah, I mean, I think for this kind of stuff, you can have multiple solutions. So one of them, because it's not really answered in this presentation, is how do you cope with rotation and configuration changes? So here what we've demonstrated is really a store that is going to live as long as the activity itself is living. So when you rotate, you got a new store. You can work around that. At Groupon, we privilege dependency injection scopes so that you can have some stuff that survives the rotation. But there are many different ways to do it, including using the view model maybe from the architecture components, or DI scopes, or you can also use a few methods from the life cycle to save your store. Then you could choose, for instance, to persist the store like on disk if you also want to survive the activity death, and not to persist this kind of events, for instance. You could also do that. But maybe in your case, what would be more uniform, I would say, would be to send a message to the store when your activity is going on pause, so that the snack bar show state is going to be cancelled and you can just move on when your activity has finished rotating.
Cool. Quick question. Have you guys considered looking at Arrow KT at all to like kind of expand on the functional concepts you guys are kind of brushing on?
Which one?
Arrow KT. It's like a functional programming library in Kotlin.
No, I don't know this one.
Okay.
But cool. Maybe you can come over after and we can talk about this extension. Yeah, thank you.
I think you had one event that could go to many actions, right?
One event, usually events are mapped to one command, and one command emits multiple actions, yeah.
Was there some sort of like logic that handles that, like a reducer?
So if there would be a comparison with a Redux Reducer, it would be at the action level, I would say. Here? No.
Yeah, the action is a reducer.
Yeah, how do you, like, if your whole app is using, does your whole app use the same reducer? How do you manage the size of that?
No. So each action is a reducer, so you can have multiple reducers. You have multiple reducers.
Yeah.
Okay.
So here, this is a reducer for the login successful, but you would have another one for the loading that will just say their login progress, something like that, right?
Okay.
And then another one for the error, that you map the error to some string maybe, and then the UI will display it. So you have multiple reducers, multiple commands, so it scales.
And could I piggyback a little bit on what he said? Like if you have an error that you flash that isn't like a toast or something that goes away, how do you not keep showing that same error? Because you could have another action that goes through right after, like a quarter second later.
Well, exactly. You could show an error.
Yeah.
Yeah. And once you show the error, you could dispatch another action to say, hey, invalidate the error. So you clear the error field.
I see. So you could send that like some period of time later or something like that.
Once you show the UI element. So
yeah.
Okay.
Well, it's just
you want to show the toast bar or the toast or the snack bar, you just dispatch another action and you clear the error.
Okay, cool.
That's it. Even your command. Yeah, even the command can do it,
Wait like after 10 seconds.
Yeah, the timing was the question that I had.
Like that,
I was wondering, how do you render the complex state on the screen? Do you use some libraries, or how do you do that?
How do we render what?
The state on the screen, on the UI.
That's really up to you. So Grox, it's not a concern of Grox. We're just going to pass the state to the UI, or let you do so actually with the Rx chain, and then that's your problem as a developer to actually display it.
Yeah, but I think a good example would be pass it through a view model, and then the view model would map the big data that you have in the store to a small data that you can then data bind or whatever you want. So there in the chain that Stéphane showed, you could have, once you subscribe to the store, you could have another map, and there you plug in your component that transforms the state. So that's it.
Okay, makes sense.
Also, to answer more completely, there was someone in the back, but yeah, as you want. Yeah, you could also add the. I forgot what I wanted to say. Yeah. Okay. Anyway, sorry about that. Yeah.
So I was working on a project where I was trying to implement the state pattern, and I came across a situation where moving from one state to other sometimes doesn't make sense. For example, if I have like say 3 commands working simultaneously, and command 1 puts my state from state 1 to state 2, command 2 puts it from state 1 to state 3. Now, because of some user action, both the commands got triggered simultaneously, and my command 2 was executed first. So my state moved from 1 to 3, but because command 1 is also executing and it was trying to put it in 1 to 2, it no longer makes sense to me. So does Grox has something where I put a mapping that, okay, moving from state 1 to state 2 makes sense, but 1 to 3 doesn't make sense if this is getting executed or something? Or will I have to manage it myself?
Yeah, so in that case, I would cancel the first one. If you have the second command, you can cancel the first one if the first one doesn't make sense anymore. So then you won't have that state change.
Okay, so I do that in the command interface.
Yeah, in the wiring. Like in the wiring, you can do that.
Okay, but you don't provide any mapping where I could...
No. No, it's up to you.
Okay, fine.
This is up to you.
Mm-hmm.
You do that like right there where you have the whole thing going in, and you cancel it.
No, I would do that once you start the second command. At click event, you say, okay, now I log out. So I unsubscribe. You just unsubscribe, and that cancels the command, so it's okay. Because once you unsubscribe, you don't get the action, the store doesn't get the action, so it doesn't change the state. So it's that easy. If you have, for example, press buy and then log out immediately, you just unsubscribe from the buy, and that's it.
Yeah, I have a question. When you click on an event and you execute some command, right? And then what happens when you reboot your device? Will the state still be available? Like, can I check the state of what happened and where am I right now? And then how, is there any timeout that I can keep track of? Something like that?
No, there's no timeout. I mean, you're in one state, you will always be in that state until some action
So
changes.
what happens if I reboot my device and then I come back and open the app and then...
Well, that depends on you. If you could serialize the state and save it and have it, or if not, you will lose it. So if you reboot the device.
So can I check like what state that particular command is at right now?
Yes, if you save it. Yeah, if you save it in the store. So as I said, if you save the loading, you start with the action. The first action, when you start the command, will save something in the state. So that's how you know.
So now when I restart the same command, is it going to be a same command or the new command?
Again, it's up to you. Yeah, it's up to you. This is up to you. Yeah.
How do you handle scoping when it comes to like, you mentioned maybe even maybe an activity would have its own store, and then can you have a global state, or do you typically have multiple state stores?
So that depends on the app, I would say. If you have a small app with a small state, you could have a state for the entire app, and that would make easy for you. But if you have a complex app like we do, each screen has its own state.
Each screen,
its own store. So you could do both.
So you can have as many stores as you want, basically, and the scoping is just however you want to handle.
And yeah, there is no real tool for scoping into Grox, but there are many different options available. I think dependency injection offers the more flexibility for scoping, because you can have these scopes that survive the rotation, but you can also have scopes that encompass multiple activities. So let's say a purchase flow, and you would like to maintain a store for consistency of the purchase action. So you could have that also with DI. So yeah, there are many options. And we have had a lot of questions of how do I do this and that. I think it's something that I see as a feature in Grox is how much freedom you got. So we just offer something that works, that lets you express a lot of things. But when it comes down to the exact problem you have, you still have to figure out the solution. And usually there are many alternatives to do so. You can play with the commands, you can play with the actions, you can play with the stores, middlewares, and so on. So you have some degree of freedom. We're not enforcing everything from within the library. Yeah.
I have a bunch of questions, actually. First question, where is the store state stored? Where is the state stored? Is it stored in memory? Is it stored in a disk somewhere?
Yes, usually in memory. And then
Okay.
you can save it on disk, for example, if you want to survive activity crash or activity finishing, you can save it in memory. But on the disk, it's in on-memory.
Doesn't doesn't Grox has an option to save my state to persist my state in disk for at least some of the attributes?
But that's really easy. Your state pointer should just be serializable, and you just write it.
But then suppose I rotate my
If you rotate, it's okay.
my
You
screen.
can use we use DI, so you survive the rotation, and that's it. You don't care. We don't care about rotation anymore. Once you rotate the screen, we just subscribe to the store again. We get the state, we display it. We don't care about the activity lifecycle.
What if my state is? What if my process is killed and then respawns again?
Then you lose your state, yeah.
Okay.
But that happens with whatever you want.
Yeah. But that's why also we said you can use the middlewares to actually persist the state so that you can reload it afterwards. That's really something you can do.
But it's not something that comes out of the box.
But there is no solution to persist the state itself. Because, as Alin said, you could make it parcelable, you can make it serializable, you can make it a JSON and save it as a JSON. So there are many options where we want to have like sharp libraries and not to enlarge the scope of the things we have to maintain and deprecate also over time. So we're not going to address that from within Grox. But you're free to choose a solution and anything should work, basically.
Okay. And second... Okay.
One last question, maybe?
I don't know if that means they're going to kill us.
Okay. I'm supposing the library is actively maintained. Are you planning to add anything else to it?
Excuse me, to add anything else to Grox? Yeah, if we have suggestions, why not? But it's been fairly stable, I would say. At the very beginning, we had 1 or 2 bugs, and since then it didn't really evolve. But yeah, we're open to suggestions. And there is a GitHub repo, so you can open issues, suggest ideas, contribute PRs even.